This is the ABET Project. I am Jose Rivera and my partner is Gabriel Cabrera, and we're going to talk about the three-phase short circuit in power systems. The project overview. We have two project overviews. The first one is the analysis of the effects of the short circuit in a three-phase power system focused on one line of the circuit, and what happened with the components of the distribution line at the three-phase load. We have the single line diagram of the three-phase system. With the data, we have to take notice. First of all, we're going to calculate the short circuit current of the circuit. Then we're going to calculate the load current of the circuit. To do this, we have to put a resistance load in series with the components of the circuit. Now, what is the DC component of the fault current? Well, we have this equation. In the equation, the first term varies sinusoidally, and the second term is aperiodic, decays exponentially with a time constant of inductance over resistance. The second term, that belongs to the DC component, appears in order to satisfy the physical condition that the current is zero at the time the switch is closed.
Good afternoon. My name is Gabriel Cabrera, and today we'll talk about what is the AC component of the fault current. Okay, in the current, in AC, have two components, the DC component and the AC component. This is a graphic of the first term varies sinusoidal belong the AC component. For example, this is the DC component, and the AC component is the variable that is sinusoidal around the DC component. For example, the variation of this AC component is the 0.5 and the variation is around this. So this is the DC component, and this variation is the AC component. In this theory, the DC component is not taken into account, and we can make that amplitude of the short current varied with respect to time. So this is the voltage and this is the time. The DC component is linear, is constant, and the AC component have an amplitude that variable is the DC component. Okay, it's important recording that in this system, the maximum value reached by the fault current depends of the DC component, the continuous part. When the short current, the circuit got to be stable, get the maximum value that have in this system. And now in this exercise, when the current of the system increase, for example this point, and the current is stable, the apparent power increase, and that causes the circuit components increase in order to get stable by the new conditions. Okay, and for example, the circuit have a initial condition in time less to 0, and when the start the circuit in a time t equal a 0, the system changes and gets stable and continue to generate a maximum value. And with these new conditions, the circuit changes, and we can calculate the voltage or current in different parts.